Hey guys, my name is Shreyas and welcome to Simple Chemistry. In this video, we're going to be talking about the photoelectric effect. Now, this really doesn't have to do that much with chemistry, and it kind of relates to what we're doing about the atom, but it doesn't really. And I don't remember seeing this on the AP chemistry test last year. There might be one question or not. It's not really an important topic, but if your teacher wants you to know this topic, then I guess this video is for you. Okay, so the photoelectric effect is very simple. So this was discovered by Albert Einstein in the early 20th century. It's what he got his Nobel Prize for. So basically what it says is that whenever you have a stream of photons, so essentially if a stream of photons is electromagnetic radiation, so we have a stream of photons with enough energy and enough intensity. Okay, so enough energy, enough intensity. Okay, intensity is the number of photons that comes, so you can think of it like a number of photons which hit the surface of the metal per second. Okay, so intensity, the number of photons, and energy is obviously like the energy of the photons, right? So and that's this yellow line right here. So whenever that's enough for a metal and it hits a metal, electrons will be released. Okay, you can think of that as, let's say you have this metal and it has an electron in the his nucleus, and then it has the electron in one of its energy levels. When it gets enough energy, it's not going to stop going up in energy levels like we talked about in the previous video. Eventually, it will just be released from the atom, because it has so much energy that it can't even go up in energy levels. It just leaves, you know? So that's what the photoelectric effect is. The binding energy is basically the energy it takes for one electron to be released, and within a metal. It changes from metal to metal, and if there's excess energy, let's say there's more energy than the binding energy, that energy will be converted into kinetic energy within the electron. So kinetic energy is energy in motion. So let's say there's like, let's say the binding energy for this is 7 times 10 to the minus 19. So let's say this energy is 8 times 10 to the minus 19. 7 times 10 to the minus 19 joules would go towards just getting the electron out of its energy levels and released from the atom, and then the last 1 times 10 to the minus 19 joules would be converted into kinetic energy in order for the electron to move. Okay, that's it for the photoelectric effect. This won't be on the AP chemistry test. I highly doubt it, but I guess it's a good thing to know in case your teacher wants you to know it. And the more you know, whatever you know can't hurt you, So the photoelectric effect is as simple as that.